Hello, everybody. I'm going to lecture about one slide that I skipped when I was lecturing about Gauss's law. The lecture explained the electric field of an infinite wire. So first I'm going to draw infinite wire, maybe a 2D perspective and 3D perspective of infinite wire. Infinite wire. See? And then along XY axis, infinite wire looks like this. So you can imagine, and this infinite wire has charge density. Charge density the common symbol for charge density is lambda, which is charge divided by unit length. Okay? So this infinite line goes from minus infinity to infinity, and you can imagine that each atoms or each position of this charge has this line charge has a charge, let's say +1 coulomb. So along one axis, so one charge will contribute to, let's say, one charge will contribute to electric field along all direction, but they get canceled by the neighboring charges. So in the end, what you have is charges that point outward. Okay? Again, this is 2D representation. And because the wire is infinite, we don't have to worry about the last, I don't know, meter, the last kilometer of the wire. Or in physics, we call it, we don't have to worry about the edge effect. Okay. So if this picture is not clear to you, I can draw a different representation, which is along, which is a 3D representation. So this is 3D basically. And you can decide which one is X, which one is Y, which one is Z. But basically, and then I'm going to switch color. For the electric field, I will draw the electric field in blue. Okay. Similarly, so this field here is due to this position, or at that position along the wire. To simplify our life, I'm just going to erase the one that I drew earlier. So now the question is, what is the electric field of this infinite line of charge or infinite wire? You may think that, okay, Rizal, you have taught us how to use Coulomb's law. Then we can just sum infinite number of charges. And then that sum, you can do it. But it's actually more complicated because Coulomb's law predicts or calculate the field at any distance. So at any given distance, you have to do infinite sum. Okay. A simpler way to do it is using Gauss's law. Okay. So again, Gauss's law, this is a good review for you. Gauss's law is flux, electric flux is equal to E A times cosine angle between E and A is the normal vector, a line that is perpendicular from the surface, is equal to the charge enclosed, the charge enclosed, which is Q enclosed, divided by epsilon naught, or your book use 4 pi K Q enclosed. Okay. And one thing that we discussed in the class already, that the area here has to be a closed area, and it doesn't have to be smooth. So we can use a symmetry. So the symmetry of a line is basically, we can use the name is cylindrical coordinates. So we can have this Gauss law. And then to simplify our life, I'll just erase some of the vectors to avoid confusion. So this area here, if I see it from the side, it looks like this area here. Okay. Right? This is basically a cylinder. When you view it from one side, this is a 3D view of the cylinder. We will use this drawing later. Okay. All right. So we can use Gauss's law. So Gauss's law says that E times A times cosine theta. First, there are three surfaces here, right? Let me just write it here. There are three surfaces, A1, A2. So A1 is here, A2 is here, and the rest is A3. So the flux is E times A times cosine theta. But for A1 and A2, there is no electric field that pass through the surfaces of A1 and A2. So for A1 and A2, the electric flux, which is EA times cosine theta, is equal to 0. Similarly, for A2, this one is also 0. This is because all electric field are perpendicular from the wire. Okay. So now all we need is A3. So A3, the electric field is E, right? And what is the area? The area is the area of a cylinder of A3 here is 2 pi r. That's the circumference of the circle here. So E times 2 pi r. R is this distance here. Okay. Times cosine theta. But we know that all the fields is perpendicular from the surface, which is parallel from the line that is perpendicular from the surface. Or in the class, we use the terms surface area and surface and normal vector. So this one is equal to cosine 0 degree, which is equal to 1. So flux is equal to 2 pi r. There is L here. L is the length here. L times E. Okay? Is that clear? So this is the flux of, so the total flux is 0 plus non-zero. So the total flux here is equal to 2 pi r L times E. This one is equal to 4 pi K. And what is the enclosed charge? Enclosed charge is the charge inside the surface, which is equal to lambda times L. Lambda is the charge density, and we can cancel L. And then we can cancel pi. We can divide 4 by 2, so we get 2. So in the end, we get E times K lambda divided by R. Okay. So to make it cleaner, I'll just copy exactly the term, which is K lambda divided by R. So that's the field of an infinitely long charge wire. I hope this lecture helps. Have a nice weekend.